Welcome to 5.5, Solve Mixture Applications with Systems of Equations. We have two objectives here, solve mixture applications and solve interest applications. In mixture, we're going to mostly focus on asset problems, the regular mixture problems like price per pound, price per ticket style problems. And we'll be looking at simple interest problems. Now, we've looked at this before in 3.3, section 3.3, where we dealt with equations with one variable. We are re-looking at these tables, but this time we're going to use this table with two variables. Okay, so it's the same table, which is good to know. So we did we're going to look at asset problems, mixture problems, investments which involve the interest, simple interest, and so on. So let's take a look at our first one. Translate a system of equations and solve. The box office at a movie theater sold 147 tickets for the evening show and receipts totaled $1,302. How many $11 adult and how many $8 adult child tickets were sold? So let's highlight the ones we have information. So a total of 147 tickets were sold. The receipts, meaning the sales, right? That was $1,302. Adult is $11 per ticket, $11 per ticket, and children is $8 per ticket. We need to know how many of each were sold. You could use the 7-step problem-solving strategy to collect the details, but the same information can be captured here in the table as well. So let's see if we're going to use this table. Well, we have to identify which template we're going to use. It's a mixture problem involving tickets, so we will use the ticket problem, and I'd like to remove the parts that involve price per pound. And we have two types, type A and type B, but now we know specifically what type we have. So this will be the adult, I'll call it A. This will be the child. Right? So we have adult tickets and child tickets. We need to see which one is, how many of each type was sold. All right, price per ticket for the adults, we saw that to be $11. Let's fill that in. For the child, it's $8. Okay, another thing, in this case, the mixture makes no sense, right? Yeah, because you're not going to mix, excuse me, you're not going to mix the adults and the children and get a new result out of it, right? So the mixture here won't be applicable. Number of tickets, do we know? We don't know. Do we know the number of child tickets? We don't know. Previously, we saw the total number of tickets and we did, well, that's a total of 147 tickets. So if adult tickets were X tickets, then children should be 147 minus that X, right? You could continue on like that, but here we're going to talk about two variables. So there are two missing details and I have two variables to bring that in. But I do know that the total number of tickets, so the mixture does not make any sense, so I'm going to call it total. And only total number of tickets and total sales makes sense, right? So that will be 147 tickets. And the table tells us what to do with these numbers. So multiply the two columns to get the last column. That will be 11x. That will be 8y. And the total sales is 1,302. And we fill that. Okay. So we got the last two columns filled. And you need two equations because you're talking about a system here. So the two equations are obtained by adding the last two columns vertically for two separate equations. So we have x plus y, right? Number of adult tickets plus number of child tickets was equal to 147. Total sales of adult tickets and total plus the total sales of child tickets gives you the total receipt. So we have x plus y equals 147. Then you have 11x plus 8y equals 1302. We got a system obtained from the table. Now we're going to use either the substitution method or the elimination method to take care of this equation. So if you are using substitution method, Equation 1 is a good choice to either solve for x or solve for y and plug that in to get plug that into your equation 2 so that you get an equation in one variable. Right? We could do that. Or we could use elimination method and multiply the first equation either by -11 or by -8 so that you have the x and the y's matching. Okay, I'm going to use elimination method. Okay. So I'm going to call first equation and multiply it by -8 because I just choose to eliminate the y's. Okay. So -8 times x plus y, -8 times 147. Equation 2 undergoes no change, as if it was multiplied by a 1. So you get 11x plus 8y equals 1302. Well, let's multiply this out. Okay. So that's going to be -8x, -8y equals, multiply these two, you get -1176. And I have 11x plus 8y equals 1302. Add the equations. That gives us 3x. Again, I used x and y, right? You could use A for adult and C for child. It's any two variables that you see appropriate. We've seen x and y's all along, so I just decided to keep it as x and y. All right, so let's subtract these two. That gives us 126. Then you divide by 3 on both sides. Using the calculator, let's see what that gives us. That gives us x equals 42. Then substitute x equals 42 in equation 1. That's the best equation. So we have x plus y equals 147. Plug in x as 42. Subtract 42 on both sides. Y equals 105. All right, this is a word problem, so you're not going to write it as an ordered pair. You won't say x comma y, although graphically it would make sense. But here, because it's a word problem, we have to come back and say what this x stood for and what this y stands for. So you know that the x, if you go back to the table, let's look at the table. The x represents the number of adult tickets, as you can see, right? And the y represents the number of child tickets. So let's come down here. The number of adult tickets is, there was no x or y given in the original problem. We used x and y, so simply say 42, or you could say adult tickets is 42. Then the number of child tickets is 105. Okay, and you do have to perform the check. It's a word problem, so check has to make sense, right? So then see if the adult tickets was $11, right, per ticket. Go back and check it out. Yes, it was 11 and the child was 8. So 11 times 42 plus 8 times the 105, the child ticket. Let's see what this comes out to be. We need to know if this is 1306. I think it was 1302. Let me fix that. 1302. Okay, we multiply them out. This comes out to be 462 plus 814. Yes, 1302 equals 1302. We got it right. So always check your answers, even in word problems. But remember to interpret your answers in the end. Let's look at the next problem. Carson wants to make 20 pounds of trail mix using nuts and chocolate chips. His budget requires that the trail mix costs him $7.60 per pound. Nuts cost $9 per pound, and chocolate chips cost $2 per pound. How many pounds of nuts and how many pounds of chocolate chips should he use? Okay. So this is a pound problem, so I remove all the ticket-related items here. What are the two things he's mixing to make the new trail mix? So he is mixing nuts, N for nuts, and chocolate chips, C, to get trail mix, right? And now we can enter the details. He wants to make 20 pounds of trail mix. Total number of pounds is 20, okay? The trail mix. And he wants the price per pound of his trail mix to be $7.60. Okay, I'm going by the order in which I see these numbers in the question. The nuts cost $9 per pound. Nuts is $9 per pound. Chocolate chips is $2 per pound. The table already says per pound, so don't write per pound in the table. Just enter the values. All right, so how many pounds of nuts? That's what they're asking. We don't know that. When we have missing information, we assign a variable. I'm going to use X. And how many pounds of chocolate chips should he use? We don't know. I'm going to call it Y. That's it. You now have to multiply these columns to get the last column. So I'll simply say 9x because it's $9, $2, so that's 2x. And this will be $7.60 times 20. Okay. Now we're going to go ahead and write out the equation from these two. Okay. X plus y equals 20. 9x plus 2y equals, multiply these two, you get 152. Okay, we could again choose to use a substitution method or elimination method. For variety, let's use substitution here. So I take the first equation, x plus y equals 20, and I want to subtract x on both sides so that I solve this for y. Okay, again, you could do minus x plus 20 and just put 20 minus x, which is totally fine. I have 1a. Then we substitute 1a in equation 2. So 9x plus 2 times y equals 152. And in the place of y, I plug in 20 minus x. That's 1a plugged in. All right, so 9x plus distribute 2 times 20, 40, minus 2 times x, 2x equals 152. Combine the like terms. So 9x minus 2x is 7x plus 40 equals 152. Subtract 40 on both sides. Seven x equals 112. Divide both sides by 7, you get x equals 16. Okay, now substitute x equals 16 in equation 1 as a suited one. So x plus y equals 20. Let's add up to 20 pounds. 16 Subtract 16 on both sides. Again, at this point, it's pretty intuitive, isn't it? Because total is 20 pounds, so you know your y must be 4 to add up to 20. Come back here and, as always, perform the check. But we also need to interpret the answer. X, so go back to the table, see what X represents. X represents the number of pounds of nuts. So number of pounds of nuts is 16. Number of pounds of chocolate chips is 4. Okay, you could either write it like this, or you could just say nuts, 16 pounds, and chocolate chips is 4 pounds, using the LBS notation for pounds. Here's the next problem. It's an asset problem. Shoshina is a lab assistant at her community college. She needs to make 200 milliliters of a 40% solution of sulfuric acid for a lab experiment. The lab has only 25% and 50% solutions in the storeroom. How much should she mix of the 25% and the 50% solutions to make the 40% solution? Again, for those heading into into nursing and any medical related allied health science studies, you will find this very helpful. And we now have to, it's quite obvious that this is an acid problem, right? You could use a visual, a story kind of a thing to see how these two things are mixed to get the new solution. But you can also use the table here to get to it directly. So acid strength given in percentage times the number of liters. Okay, do we have them in liters? Well, we have them in milliliters, so all this could be written in terms of milliliters, right? So let me rewrite that as milliliters, MLS. Okay, and acid amount is the last column. Okay, so solution A, where are we? Yes, solution A is 25%, solution B is 50%, right? That's the strength of the acid in each of those solutions. Those are the two types that they have, and they want to mix these two strengths to get a new solution of strength 40%. Okay. Let's understand that. I don't want to cross it off. Solution A is 25% concentration. Solution B is 50% concentration. The new solution must be in between, and they say they want it to be 40%. Okay. Now we know the strength, we really don't know the number of milliliters to obtain from each of those solutions, A and B. Okay, so let's scan the problem. She needs to make 200 milliliters. Okay. 200 milliliters is the total number of milliliters of the new solution. So let's write that as 200 here. Okay. And the solution strength for the new solution is 40%. So we write it as 0.40, right? 2 decimal places to the left. 0.40 is the same as 0.4, but just for clarity, let's write it like that. Acid strength of solution A was 25%, so it's 0.25. And acid strength of solution B is 50%, 0.50. Okay. Now we do not know the number of units, right? Number of milliliters of solution A, so we're going to call it X. We don't know about solution B either. We're going to call it Y. We can begin to see that it's very similar to the other problems we did. Multiply them all to get the last column. Okay, that's going to be 0.25x, 0.50y, and this is 0.40 times 200. Okay, Now we're going to write the equations out here from the last two columns. So x plus y is 200. 0.25x plus 0.50y equals, and again from your calculator, that comes out to be 80. Okay. You could keep the decimals as they are, or you could clear the decimals, right? So let's call them equations 1 and 2. Okay. If you're using the calculator, clearing the decimals need not be done. We're going to use, let's say, elimination method here. So I multiply the first equation by, we need a negative sign as well, so by negative 0.5, 0 if you want. All right, so that gives us negative 0.5x, negative 0.5y equals 200 times negative 0.5 is negative 100. And equation 2 stays the same. Negative 0.25x plus 0.5y equals 80. This middle one goes away. Use your calculator, and that gives you, I put a negative here, I'm sorry, yeah, positive. Okay, use the calculator, and that gives you negative 0.25x equals, that's a negative 20. Divide both sides by negative 0.25. Now, when you look at the negatives, it should give you a slight, jolt to see, hey, I'm talking about the number of milliliters, I'm getting something negative. But you can see that both sides were negative, so right now the negative sign is being taken care of. It's being removed because negative 20 over negative 0.25 actually gives you a positive quantity. It's 80. Okay. Now, if you got a negative quantity, you should be worried because it is obviously a wrong answer, right? This is 80 milliliters, so you can't have negative 80. So we got the right thing, so we can move on. Then we substitute x equals 80 in equation 1. So we have x plus y equals, it was 200 milliliters. So x is 80. Again, at this point, it's intuitive. You know that they must add up to 200. So if you are already using 80 for one solution, the other one must be 120. Perform the check, come here and conclude. So 25% acid solution, we need to take 80 milliliters of it. Okay. And for the 50% acid solution, we need to take 120 milliliters. I write it in words for the other one because sometimes they just use ml, sometimes they use mls. So let me rewrite that also as milliliters. Okay. That way we're safe, whatever notation is used. So check the answer, see if it makes sense. They must add up to 200, and when you measure their strengths against the number of milliliters, you get the acid amount also matching up. That's your acid solution problem. Then the last problem is an investment problem. Adnan has $40,000 to invest and hopes to earn 7.1% interest per year. He will put some of the money into a stock fund that earns 8% per year and the rest into bonds that earns 3% per year. How much money should he put into each fund? Okay. Mixture means obviously they're taking two things and mixing them up. Right? But here you have to understand what's happening in an investment problem. It is similar, but you still have to know what's going on. Okay, so Adnan has $40,000 pot. Okay, and he wants to take money from this pot and put it in one investment which earns 7.1%, and another one that earns oops, I'm sorry, I misread it. He wants to earn 7.1 interest per year out of that $40,000. But he's going to break that into two funds, and he's going to put one part in 8% investment and the other part in 3% investment. So we're trying to see how much should he invest in each of these so that at the end he earns 7.1% interest. Okay, so we will take care of that in the table. So Fund A, what was this fund? It was a stock, right? That was a stock fund. And Fund B was in bonds. That's what we have. And the total, right, that is the overall interest he expects from his total of $40,000. So let's enter the details. So the total principal is, that's the total amount he's willing to invest, right? We don't know how much of that $40,000 he's going to invest in the stock, so we'll call it X. And we don't know how much in bonds, that will be Y. The interest rate for stocks is 8%, 0.08. And the rest he's investing in the bonds that earns 3% per year. It's right there. That's 0.03. But on a total count, he wants 7.1%, right? So that's 2 decimal places to the left, so 0.071. And all this is a duration of 1 year, so time is 1. The columns are to be multiplied to get the last column. .08x, 0.03y, and 40,000 times 0.071. Let's build our equations here. This time our equations come from the P column and the I column, right? Because you're basically looking for columns that have X and Y, because that's how you can build your equation, right? The R column has no X or Y, and that is anyway not being used. So X plus Y equals 40,000. Again, in your calculations, you don't have to put the dollar value. And this will be 0.08x plus 0.03y equals, multiply those two, that comes out to be 2840. As always, you could choose to clear the decimals or keep them as they are and go ahead with the problem. Equation 1, I want to multiply, I need a negative, and let's say 0.03. Equation 2 will remain as it is. Negative 0.03 times x plus y, negative 0.03 times 40,000. That's equation 1. Equation 2 is 0.08x, 0.03y equals 2840. Distribute to build the actual equations that will use the elimination method. Those two multiply to give us negative 1200. The middle term cancels off. That is 5, right? So 0.05x equals 1640. Divide both sides by 0.05. X equals 32,800. And then substitute X equals 32,800 in equation 1. they must add up to 40,000. So you can already see that we have to subtract this amount from the 40,000. Let's plug in 32,800. Subtract that on both sides. Y equals 7,200. We got our X and Y. Go back to the table and see what X represents. X represents the stocks and Y represents the bonds. X gave a high interest rate, right, 8%. It makes more sense that he would do bulk of his investment in that which produces or earns more interest. So let's say here interpretation is stocks, investment will be $32,800. Please use your units. And the bonds investment will be $7,200. As always, perform the check. This gives us our answer for investment problem. I hope you enjoyed this section. I will see you in the next one. Bye.